All right, guys, welcome back to day 4 of our RPS at home lesson schedule. Today we'll be looking at circles and practical problems. All right, so today yesterday we focused on calculating the area and the circumference of a circle using drag charts, and we'll do a little bit of that today to kind of help us gather our information. But today we're going to look at those practical problems and what does that mean when we say that, practical problems. All right, so I want you to do this for your opening exercise. I want you to tell me what are some strategies you use to solve word problems. Okay, so you can pause the video, and as always, this worksheet for this lesson is available to you at RPS at home, and you can download it, print it, and follow along, or you can just have a sheet of paper and just go ahead and take these notes along with it, and we could go through this step by step together. All right, but tell me, what are some strategies you use to solve word problems? Think about that for a few seconds. All right, pause the video and I'll be back. All right, so assuming you did that, the strategy that we're going to be using today, okay, and maybe you said this, is called cubes, okay, where each letter represents a certain step in solving a word problem. It's a nice way to kind of organize our thoughts and really just peel back the problem to get the answer that it's asking for. All right, so cubes, each letter stands for something, right? So the C, it stands for circle the numbers, okay? So you're gonna circle the numbers. The U stands for underline the question, all right? So wherever the question is in the word problem, you're gonna underline it, okay? Here's probably the most important part, box the keywords and the phrases. All right, so what does this mean? Okay, we're going to take a little second here. We're going to pause right here. What are some keywords and some phrases? And again, what we're talking about is area and perimeter. So what are some keywords and phrases that involve area or perimeter? All right, so what I'm going to do is I'm going to detail that for you, all right, using my whiteboard, okay? And I want you to jot these down. Now, these aren't all of them, okay? But these kind of give you the idea of what you're looking for, okay? So we're in a situation now where we're not going to tell you, the word problem is going to tell you, now you have to calculate the area. It may happen, but probably not. If it does tell you, it's easy, but you're going to be reading word problems and you're going to have to find keywords that tell you, okay, I need to calculate the area of this circle, okay? Or not perimeter. What is the perimeter of a circle called? All right, what we're really talking about is the circumference. All right, so you might want to write these down in your notes, okay? If it says space inside, right? Carpet, if you're calculating carpet, cover, covering something, tiles, right? Square units. Those are things that tell you, okay, I need to calculate the area of this circle. Whereas if you're reading the word problem and you see things like edges, trim, you need to find out how much fence you need, how much border, it's going around, it's on the outside. Those are all things that should tell you, okay, I need to find the circumference in order to answer this question, okay? So that's really what we're going to be working on today, okay? How do we go about using, all right, these keywords to kind of guide our steps in answering the question, okay? So let's look at some other examples. Oh, well, our cubes here, the E stands for evaluate, strategies for answers. So you're going to be, after you get the box of keywords, then you're going to say, all right, now how do I do that? What am I actually what do I have to do in order to use the area formula or the circumference formula accurately, okay? And then last but not least, finally, is just put it into play, right? Solve it, right? And then of course, you always want to check your work, okay? So that's that, right? So what I want to do is I want to do this word problem, right? And we're going to use cubes to kind of, um, uh, uh, to answer this question. All right, so cubes, right? So first of all, you got to read the question, okay? Don't just go circling numbers right off the top, right? First, read the question carefully, all right? And then use cubes, okay? So the question reads, Gina planned on cleaning her circular pool. After draining the water, she had to spray cleaner on the entire bottom. If the diameter of the pool is 25 feet, how much spray will she need to cover the bottom of the pool? Okay, so cubes, circle the numbers. All right, so I'm going to circle here the 25 feet. Okay, cubes, the U stands for underline the question. So I'm going to underline the question. How much spray will she need to cover the bottom of the pool? All right. B, box the keywords. Now, the keywords, again, go back to those things that we talked about previously, right? Area and circumference. What are those keywords that we're going to use? Well, if we remember, cover was one of those big keywords that told us what? Under what column did we find cover? Okay. And then we have to think about it. Well, cover was an area word, right? So we're going to have to find the area in order to answer this question. But we're going to complete the entire chart here, okay? Because I want to be able to make sure that we understand how to use it still, right? And sometimes you might have to know both, okay? So we know we got to find the area. That's part of our evaluating. So we're going to have to do pi times the radius squared. So we're going to have to figure out the radius in order to do this. Well, we know that the diameter, right, is 25 feet. So I'm going to put 25 here. Ooh, that doesn't look good. Let's type it in. How about that? So 25, right, and I'm going to make that visible here. And it is feet. So 25 feet here go under the diameter. And then the radius is half of that, right? So what is half of 25? In other words, what is 25 divided by 2? Well, 25 divided by 2, if you use your calculator, you'll see that 25 divided by 2 is 12.5. So our radius is 12.5 feet. All right. So now we're going to figure out the area, right? The area is going to be pi times that radius squared, right? So if I clone this here, that's my radius that I'm going to square. All right. And I'm going to do this, right? And I'm going to multiply it by pi. Where's my pi button? Pi times 12.5 to the second power. So I got to have an exponent of 2. That's what my area is going to be. Pi times 12.5 squared. So as always, we're going to use our Desmos calculator. All right, we're going to hit our FUNC button. Pi. Go back to our main times 12.5. And then we're going to square that. And look at what we get. 490 0.87, right? Because it is 3 right here, it doesn't round up, it stays at 87 hundredths. So 490 and 87 hundredths is our area. 490.87 hundredths. Oh, what happened here? Gotta take that off. 490.87 feet squared. That's how much area she's going to have to spray. All right. And then, of course, we want to finish this off with our circumference calculation, which is just pi times the diameter. Right. No need to square it. Right. Again, our diameter is in that first column. Our diameter is 25. All right. So if you're not sure where that came from, remember the diameter is what we're substituting in here for the circumference formula. Right? And we know that our diameter is 25. Okay? So pi times 25. So we go to our Desmos calculator here. Pi times 25. And we hit the equals button, or we don't have to, it's already calculated for us. 78.539. So that 9 tells us to round our hundredths place. We're just rounding to the hundredths here. All right. 78.54. So 78.54 feet is the circumference of that pool. 78.54. 78.4. Okay, and units is very important actually. Feet. Okay, so this is what I want you working on. Okay, now again, in your worksheet, it has our 3 problems that we're going to do. All right, but what we're going to have to do if you don't have the sheet in front of you, we'll just go question by question, 3 problems, 1 step at a time, right? You can pause the video, right? So it's your turn now. All right, so here's question number 1. All right, using cubes, I want you to answer this question. Pause the video and then hit play and see if you got it right. All right, so let's see if you did it correctly, okay? A spotlight can be adjusted to effectively light a circle of up to 6 meters in diameter. How much of the stage does the spotlight cover? Okay, so here we're going to use our cubes, all right? We're going to circle the number. We're going to underline the question, all right? The question here is, how much of the stage does the spotlight cover? All right, now we're going to box those keywords here, right? Now, let's see, what is that word that tells us that we're dealing with either area or the circumference, either the inside or the outside? Well, here it is, cover. If you're covering something with light using a spotlight, right, that should tell you we're dealing with area, right? That's where our answer is going to be, our area, okay? And so we're going to have to figure out what the radius is, right? We don't have the radius just yet. We do have the diameter though, okay? So that's pretty important as well, okay? And the diameter here is 6, okay? So let's go ahead and put that 6 where it belongs, right? The diameter belongs right here. That doesn't look very good, does it? All right, so let's type again. 6 meters. Okay, so here is our 6 meters. Okay, and I'm gonna make this a little smaller so it can fit. So there's our diameter. Now, what is the radius? Well, the radius is half of the diameter. Well, if we know that the diameter is 6, what's half of that? In other words, 6 divided by 2. Whenever you take half of something, you divide it. What is 6 divided by 2? Well, that tells us that the radius of this spotlight is 3 meters. Okay. Now, how much space does it cover? Well, it covers pi times the radius squared. Okay. So pi times something squared. All right. Well, we know that the radius is we just figured it out, right? What is the radius? Well, the radius is 3. We have it right there. It's written down in our in our chart. Here's our radius. So it's pi times the radius squared, right? To the second power. Whoop. To the second power. All right, so we're going to go use our calculator. Pi times 3 squared will give us that area. Okay, so clear it. All right, pi times 3 squared. And there you see it's 28.27. The 4 tells it to stay there. The 7 does not round up. 28.27 is our area. 28.27. And that is meters to the second power. Meters squared. Okay? So that's the area. And that answers the question. But let's figure out the circumference. Okay? The circumference is just pi times the diameter. So in other words, it's pi times, what's the diameter? The diameter is 6. Okay? Where do I get that 6 from? Again, this 6 is the diameter. Here's our diameter column, 6 meters, right? So we're substituting, right, into our equation, and we just got to use our calculator and just do pi times 6. All right, so let's do it. Pi times 6. Clear that. Pi button times 6. And there we see it's 18.849. So that 4 is going to round up. So it's going to be 18.85. 18.85. And what is our units? 18.85 meters, right? Not squared, it's not area, all right? But how much of the stage does the spotlight cover? Our answer is right here, okay? That's our answer, okay? 28.27 square meters. And we know it's talking about the area because of our keyword cover. So that is the answer to our question, okay? Number 2, all right, you go ahead and do that, okay? All right, and again, this is on your worksheet on RPS at home, okay? But we could do it one by one, all right? So assuming you pause the video, all right, you read the question, and then we're gonna use cubes. All right, so the Coliseum pool at the resort at Pelican Hill in Rome is one of the largest circular pools in the world. It has a diameter of 136 feet. How much cushion would be needed in order to surround the entire pool? All right, so let's go ahead and use our cubes. C stands for circle the number. Cubes, U is the next thing. Underline the question. How much cushion would be needed in order to surround the entire pool? Now we're going to box the keyword that tells us whether we're dealing with the area or perimeter problem or circumference problem, excuse me, what do you think is that key word in here? All right, that tells us that it's either area or perimeter. Well, guess what? This is the guy right here. Surround. Okay. If you're surrounding something, you could almost hear the word in there. You're going around it, right? So sometimes there's cushion on the outside of the pool, right? And if they're going to put cushion, how much would be needed around the entire pool? Okay. So we're going to find the circumference of the pool by multiplying pi times the diameter. Well, we know the diameter. We have our DRAC chart. Let's go ahead and fill it out here. Okay. What is the diameter? This first column, it says it's 136 feet. So I'm going to go ahead and do that. And let's not forget our units. 136 feet is the diameter. I'm going to put that guy right here. All right. Which means the radius is what? Well, the radius is half of the diameter, right? The diameter divided by 2. So what is 136 divided by 2? Well, 136 divided by 2, I should have used my Desmos for this, but I'm already into it, equals 68. So our radius is 68, okay? Just didn't feel like trying to figure it out off the top. But that's why we have calculators. 68 feet, okay? Now, the area of the pool, right? Even though that's not going to give us the answer to the question, let's practice calculating our area. Our area is going to be pi times the radius squared. So I'm going to use my pi button. Pi times the radius, 68, and then we're going to square that, all right, using our Desmos, and that'll tell us the area of this pool. All right, so pi times 68 squared. Nope, not that one. Desmos. Clear it. Pi times 68 squared. All right, let me slide this back down here. Creeped over like that. All right, so pi times 68 squared. And there we see it's 14,526.724. So that 4 tells us that the 2 is going to remain the same. It's not going to round up. 14,526. 14,526.72. I don't know if I'm going to remember that. 14,526. 14,526 point, what was it? 72. And this is feet squared, so it's to the second power. Okay, area is always squared. Let me just make sure that's correct. 14,526.72. We're good. And then finally, pi times the diameter is going to give us the circumference, and this will answer the question. All right, so the diameter is 136. So if we use our calculator and we just do pi times 136, we'll have our answer. All right, pi times 136, and we see it's 427.256. So that 6 next to the 5 tells us it's going to round up. So it's 427.26. 427.26. 427.26. 427.26, and this is just right? Area is the only one that has a square unit measurement, okay? So how much cushion would be needed in order to surround the entire pool? There's our answer right there. They're going to need 427 and 26 feet of cushion. All right. Last question, number 3. All right. Pause the video. See if you can figure it out. All right. So assuming that you read the question, you used cubes, right? So if you used cubes accurately, right, you would have said, all right, let's circle that number 12. Let's underline the question. There's 2 questions in this one. Okay. Box the keywords. What do you think are the big keywords in this question? Oh, let's read it. The circular display in the Maymont Japanese garden in Richmond, Virginia needed new fencing. It also needed to be completely seeded before springtime. If the display has a radius of 12 feet, how much fence will be needed? How much seeding would be needed? Okay, so I jumped the gun. Classic mistake that is made, not reading it before you use cubes. You always read first and then you use cubes. So don't do what I just did right there. All right, but so we're gonna we circled the number, we underlined the. Now, what was the big keyword that tells us whether it's an area or a circumference problem, right? Well, fence, okay, means something. If you remember from our chart, fencing, if you're talking about putting fencing around a garden, what are we talking about, right? Fencing has to do with circumference, okay? And there's also a word in here that's pretty important here, seeding, right? Now, if you're seeding a garden, right, what do you think you're doing there? Are you uh, putting it around the outside or are you filling in the inside, right? Seeding, all right, is filling in the inside, right? So this has to do with the area, okay? So we got to fill in these blanks here, right? So we're going to put our 12 where? Where does the 12 feet belong? Well, 12 feet, it says that it is the radius, so it belongs right here, okay? Now, what is the diameter? Well, if the radius is 12, the diameter is twice the radius, 2 times that, right? So what is 2 times 12? That's the diameter, 2 r's, 2r, the r is 12, 2 times 12, well, that's 24, right? So this is 24 feet. All right, now we got to do both of these to get the answer to this question. The area is pi times the radius squared. Okay, so it's this guy, and we're going to square it, pi times the radius squared. All right, well, that there, and pi is multiplying the radius squared. So here we have it. Pi times the 12 squared. All right, so what is pi times, let me get rid of it. What is pi times 12 squared? Well, pi times 12 squared. All right, so let's clear that. Pi, oh, clear it. Okay, pi times 12 squared is 452.389. That 9 tells us to round up to 8, so 452.39. 452.39 trying to remember it. 452.39 feet squared. All right, and then finally, our circumference is just pi times the diameter. All right, so if we were to substitute in this equation, what is the diameter? Well, the diameter, first of all, let's get rid of that square because we don't square the diameter, we square the radius. But the diameter was 24. So it's going to be pi times 24. So let's clear this. Pi times 24, 75.398. Ooh, so that 9 needs to round up to a 10. In other words, that 39 hundredths becomes 40 hundredths. So 75.40 is our answer. 79, what was it, 79? 75.40, excuse me. 75.40. 40. And that is not square feet, just feet. So that's how much fencing they're going to need. So how much fencing are they going to need? Fencing, they're going to need 75 and 40 hundredths foot, 76 feet, right? We just call it 76 feet. And how much seating are they going to need? Well, they're going to need 452 and 39 hundredths square feet of seating for the big circular display at Maymont. All right, so that's that. All right, so talk to you again tomorrow for our problem of the day. We're going to stop here, and good job. All right, if you need extra work, you know we have some extra worksheets there on RPS at home. All right, talk to you tomorrow.